Welcome students of class 12. I welcome you once again on the offline classes. This is on the chapter that is coordination chemistry. We are discussing on this chapter that is coordination chemistry. Today is the part that is the next part from the nomenclature. Last day we have discussed nomenclature. The online session will be also on this part, but it is offline videos. Those who still have not seen the videos, it is specially for them. Now, isomerism is an important part of coordination chemistry. What is isomers? That the molecules having the same, the compounds having the same molecular formula but different in properties is known as isomers. Now, the examples are D-glucose, glucose and fructose. These are an example of isomers, right? Now, the isomers are differentiated in two different ways. That means by two ways we can differentiate, we can classify, not differentiate, we can classify the coordination isomers. So first of all, there is two ways. Then what are the types of isomer? First of all, it is structural isomer. So structural isomer, from the name, that is it differ in the structure. That is in the, we know the two zone of the coordination compounds, that is inner zone and outer zone, and also the structure means there is the important part was the ligand. Now, the attachment of ligand and the distribution or the spatial arrangement of ligands is will be discussed in this part. Now, first of all, the structural isomer is the ionization isomer. Ionization isomer, right? Next two is the hydrate isomerism. Hydrate isomer. So first one is the ionization isomer, second one is the hydrate isomer, third one is coordination isomer. Coordination isomer, and fourth one is linkage isomer. Linkage isomer. And out of stereoisomer, what is stereoisomer? Here, as the stereo terms relate to the there is the concept of three-dimensional figure. That means stereo is a term that is represents us about the arrangement of the different groups. Now, when the term that is 3D term is there, that means not 2D, then the stereo comes, that is the it comes with the arrangement with a bond angle in the three-dimensional space. Now, stereoisomer, first of all, it is the geometrical isomer, popularly called cis-trans isomer, and another one is the, first of all, it is geometrical, and another one is the optical isomer. Right, so first of all geometrical and second one optical. Now coming to the detail of that. So first of all, structural isomer. Then out of structural isomer, first is the ionization isomer. Ionization isomer. So ionization isomer, that means which ionize in different way, in the solution. So here the difference in the ionization. One example of this type is that CO NH3 5 time SO4 Br and CO NH3 5 time Br SO4. Now follow the structure. Both of these are isomer to each another. Now what happens here, when it dissociate, first one dissociate to produce this one plus, this one minus, and second one dissociate to produce this plus, this 2 minus, this plus, this 2 minus, that is 2 plus, right? Now here is the difference. That means in the first case the bromine minus ion will be there, and in the second case it will be the sulfate ion will be as a free ion, and the further part is the complex entity. Another one example of this kind is, this is one. Another one, compound of cobalt CO NH3 4 times, NH3 4 times Cl2, and out of the bracket it is NO2, and another one will be just CO NH3 4 times Cl, right, and out of the coordination sphere it is Cl2, it is Cl. So the change in position of NO2 group, that is nitro group, in first example it is out of the coordination sphere, and the second it is in the coordination entity, so in the inner zone or in the inner atmosphere. So here first of all it is ionizes to form this plus, this minus, and here it forms this plus, this minus. So this is also an example of ionization isomer. So when the compounds ionizes differently but having same molecular formula, then it is known as an ionization isomer. Next one is the hydrate isomerism. So hydrate isomerism, so hydrate, that means hydro, that is aqua. When water is a ligand in any complex compound, then the term that is hydrate isomers come. Now hydrate isomerism is differ in the number of water molecule as ligand, differ in the number of water molecule as ligand. So here the number of water molecule in the coordination sphere and out of the coordination sphere will be different. Just follow the example. Cr, next one is the hydrate isomer, hydrate isomerism. One example, Cr H2O 6 times Cl3, and another one of same kind, that is Cr H2O whole 5 Cl Cl2 H2O, right? So here in the first case what we have seen, that the number of water molecules as a ligand in the coordination entity is 6, but in the second case it is 5, right? Another one example of such kind, that is Cr H2O whole 4 Cl Cl2 2H2O, right? So these are the examples of hydrate isomerism or hydrate isomer. Next one is the coordination isomer. Coordination isomer, that means the compound formed with the same metal but different ligand. For example, a compound of cobalt, coordination isomer. Just follow the example. CO NH3 6 times Cr Cn 6 times. So if you follow that, one will be cationic part and another one is anionic part. So it is one example of that. Now reverse of that is CO Cn whole 6 Cr NH3 whole 6. So what is the change? That ammonia was in the first one, ammonia is with cobalt, whereas the cyanide is with that of the chromium. In the next case, just the reverse, that is cyanide is with cobalt but ammonia is with chromium atom. So it is the part of coordination isomer. So what happens there? The ligand change its position from one metal atom to another metal atom, right? It is an example of coordination isomer. Another one, that is Cu NH3 whole 4, CuNH3 whole 4, PtCl4, and another one is CuCl4, PtNH3 whole 4, right? So these are another one example of coordination isomerism. Fourth one is the ligand isomerism. So here, as the ligand like nitro, NO2, it can make bonds with nitrogen atom and also with oxygen atom, right? So this type of isomers is known as linkage isomer when the same ligand attach with the central metal atom but with different donor center. When a ligand make bonds with central metal atom with different donor center. The first one is with nitro, that is one N donor center, that is nitro N, nitrito N. Another one is nitrito O. In the same way, NCS and SCN, thiocyanate N and thiocyanate isothiocyanate. One is thiocyanate, another one is isothiocyanate. So these are the examples of linkage isomerism. Next one example is part of geometrical isomers. Now geometrical isomers, when there it is also depends on the ligand, that is geometrical. It also depends on the ligand. Here, as the position of the ligand is different, then is the name. So here cis trans isomer. Now what is cis, what is trans, right? So when a same ligand is adjacent to each another, then it is called as a cis isomer. That is for a square planar complex. We know square planar complex. Here is the metal ligand. Now I displace L by A and B. Now these two A are attached to each other or adjacent to each other, so it will be called as cis. And what will be the reverse case? That when such kind of bonding is there, that the same ligand is opposite to each another, then it will be a trans. So when the same ligand is adjacent to each another, then it is called as cis, and when it is opposite to each another, that is there is the bond angle is 180 degree, then it will be called as trans, that is opposite to each another. Now it is for the coordination number 4. Now coordination number 4, here only the square planar complex come or exist as a geometrical isomer. Now in the square planar complex there are different number of ligands will be there. Here we have taken a general example of MA2B2, right? The general example is MA2B2. So for such kind of complexes, the figure will be like that. But if the composition is different, it may be a bidentate ligand is there, it may be a A3B type compound is there, A3B, A4, or MAB3, right? This composition also possible, but when a tetrahedral complex is there, for example MA4, now here no geometrical isomers will be possible because all the positions are equivalent. All the positions are equivalent here, but in case of MA2B2, and there are few more examples regarding that. That is the example of MA2BC, MAB whole 2. We know the bidental ligand, that is AB, and also MABCD. So these are the different types of compounds which arises with the geometrical isomer. So first of all, Ma2B2 I just discussed here. So example of Ma2B2 type compound is an example of PT platinum. Platinum NH3 whole twice Cl2. Here Ma2B2. Both of that are monodentate ligand. Now the figure will be platinum NH3 Cl. Another one is platinum NH3 Cl. Now according to the definition, it is cis and it is trans. Now there will be a confusion that if we displace the bond position, that is if we write down NH3 here and here and Cl here, it will also be the cis because two NH3 are in adjacent to each another. Next one example of Ma2BC. The examples is Ma2BC. This was the example of Ma2B2. Next one is Ma2BC. Right? Now from general rule we can tell that when A is adjacent to each another, then it will be cis, and when A are opposite to each another, it will be trans. Now follow the example, that is platinum NH3 whole twice Cl NO2. Right? So the figure will be Cl NO2 NH3 it is 6, and PT NH3 Cl NO2, it will be trans. Right? So this one example of Ma2BC. Right? Next example or next type of compound is MAB whole twice. MAB whole twice. So here AB is a bidentate ligand. MAB whole twice. Examples of this is platinum glycine whole twice. Now glycine having two donor atom. When we show the when we discussed about the ligands, then glycinate is the two donor center. That is, one is anionic and another one is neutral. One is NH2 CH2 COO minus. So these are the two donor atoms. Now when the same donor atom, that is nitrogen, is adjacent to each another, then it will be trans, and when the nitrogen will be opposite, then it will be when nitrogen is adjacent, then it will be cis. When nitrogen is opposite to each another, it will be trans. Just follow the picture, that is platinum NH2 CH2 COO minus. Here NH2 CH2 COO minus. So it will be the cis because two nitrogen donor center are adjacent to each another, and the reverse one may be just the opposite of that, that is Pt, NH2, NH2, COO minus, and here CH2, and here CH2, COO minus, CH2. So it is the trans isomer. So in this way, the bidental ligand also forms a geometrical isomer. Another one example, that is MABCD type. MABCD. MABCD. So here, from the general formula, we can tell that all the ligands are different. Examples of these here, one example is platinum NH3, platinum NH3 H2O, Cl NO2 Py. Overall symbol is plus. So it is an example of MABCD type complex. Now, in that type of complex, we have to fix one ligand and displace the rest one. We have to fix one and we have to displace the next one. For example, if we fix, suppose platinum is there. Now NH3 is drawn here. Now H2O, Py, NO2, NH3, platinum, that is NO2, H2O, Py, platinum, NH3. Here it will be pyridine, it is NO2, it is H2O. So there are three possible isomers for the type ABCD, MABCD type complexes. So what we have seen up to that, the geometrical isomers comes with the coordination number, that is 4, and we know the with 4 coordination number, here the geometry possible is square planar and the and the tetrahedral. But in tetrahedral complex, as all the positions are adjacent, as all the positions are equivalent, then here no geometrical isomers will be possible. But in case of square planar complex, the examples are A2B2, A2BC, or MAB whole twice, or MABCD type. So in first 3 cases there are 2 number of isomers, that is 2 isomers, and in the fourth one here the 3 isomers will be possible, that is geometrical isomers will be possible. The examples are also discussed on this respect, right? Now this is all about the geometrical isomers. This is all about for the geometrical isomers for square planar complexes. Now the left part is geometrical isomers of octahedral complexes, which will be discussed on the next class. Now the octahedral geometry, we know there is 6 ligand. It will be more difficult than the square planar. So in the geometrical isomer for octahedral complex, that is with 6 ligand, will be discussed on the next class. Keep watching on the offline and online classes, and online classes will be of more enthusiastic to you, because there is a direct interaction will be there from your end. So I hope both of the videos will help you to proceed to the chapters, and you keep studying on the topic, that is in between the topic, that is those the chapters which was already completed and which will be completed in the upcoming sessions. So keep attention on your studies because your board exam will be on time. I hope all the situations will be as normal as previous. So keep attention on studies and uh, follow the online and offline classes. So I will be back on the next videos with you and taking the same topic, that is geometrical isomers with octahedral complexes. Till then, have a nice time.